Hi everyone. We are pleased to present our topic at ZAPCon. As ZAP is one of the open source tool with having great community support and huge community base. One of my favorite. So let's start our session. First of all, who are we? So myself, Ankush Mohanty. This is my Twitter ID. If you want, then you can follow me. Otherwise, not. So I am a security analyst, having more than 6 years of industry experience, and I have been initiated the OWSP Cuttack chapter at my regional area. So during my student career, I was a bug hunter also. And I am very much interested in drones and SDR software defined radios. Those are my areas. So my co-host is Milan. Milan, could you introduce yourself?
Hello everyone, I am Milan Sen. Currently I am working as a security architect and I am into application security field almost since 2010. So that's a long time actually. I joined OWSP Cuttack chapter in 2018. I have been a member of it since. And also, apart from application security or mobile security, I'm also interested into hardware and IoT security as well. So that's just a brief introduction about me.
Okay, so I think we all introduced ourselves. So let's initiate our topic. These are some main points we'll cover in this session. So first we'll show how to set up OWSP ZAP with various environment like iOS and Android. Those are the two most known environments, mobile device environments. Prerequisites, what are the necessary stuff we need to set up this scenario and configuration. Configuring OWSP ZAP with iOS device and configuring OWSP ZAP with Android device. And we will explain whether we should go with emulator or not. Then how we can analyze the traffic of mobile application with the server using OWSP ZAP. So these are some points. This is our basic setup. How we are means how the this scenario, this setup is going on, means how the OWSP ZAP can intercept the traffic between mobile device and mobile server, and we can analyze those traffic for finding vulnerabilities. And even ZAP has some capability to finding some vulnerabilities. So this is the and one most important point is mobile device and the system, desktop / laptop, where the OWSP ZAP installed should be in the same network. Okay. So the prerequisite is first, as we are presenting OWSP ZAP, so we need to install the OWSP ZAP in a compatible system. So there are three systems, three laptop OS available, Windows, Mac OS, Linux, and other. So in most of OS, the OWSP ZAP support. So we need to configure our device, laptop or desktop according to the compatibility of ZAP, because generally it is 4 GB of RAM and the necessary hardware required. So mobile device and emulator, because we are presenting how to analyze the mobile application security using ZAP, so it is required. So we have two options: mobile device and emulator. But for our test cases, we generally we are preferring the mobile devices. So again, we are repeating both the ZAP and ZAP system, where the ZAP is installed and the mobile device should be in the should be in the same network, like in the same Wi-Fi network. So the most important thing is ZAP root certificate. CA, which is necessary to initiate the communication with WSP means ZAP to the mobile server through SSL TLS communication. Means if we want to initiate the secure communication and intercept that, then root CA is a mandatory requirement. So how to do that? So in the OWSP ZAP tool option, there dynamic certificate, then generate. If we want to create a new certificate, then we have to click generate and save. Otherwise, it is there already. We have to just save and to our desirable place. That's all for prerequisite. So now configuring ZAP with iOS device. So the problem with iOS device is we can directly take the iOS the root CA certificate from the system, from the desktop or laptop to the mobile device. So we can do that directly. Okay. So to avoid this limitation, we can either mail from the system to the mobile device, or we can use some other media like available in market like Gender, Share It, those. Here we just hosted a simple HTTP server in our system, Python based, to download the certificate into in our iOS device. So to initiate the simple HTTP server, here we are using simple HTTP server can be hosted in Python 2. It is not supported for Python 3. So the command is Python 2 -m space simple capital S SIMPLE HTTP capital server is capital. Both are in a single word and space the desired port. Here we are hosting our server with a port 8888 4x8. So this is our configuration to download the root CA certificate. Again, continuing that. So once we to download that certificate, first we need to configure the proxy. To configure the proxy, just we have this is the screenshot we have added. We have to go to the settings, then the Wi-Fi. There, choose your desired Wi-Fi network. There you can find the proxy setting. Click there, and by default it is off. So we need to click on manual. There you can just provide your IP address. Here our IP address is 192.168.29.13. So it will be changed for according to the environment and your case. So that's all to configure the proxy. Once the proxy is configured, we need to download the root CA certificate, as I explained already. Once the root CA certificate is downloaded, we need to we need to install that certificate. To install that certificate, it is only once you download that certificate, it will ask to install. You just click allow, then it will be stored. So how you can get that certificate? To get that certificate, go to setting again. In the setting, once you open that setting, there will be one additional menu will find. That is in that menu you will find that profile downloaded. So click on that profile and save that. Just click on follow the instruction. The certificate will be installed. Once the certificate will be installed, we need to enable that certificate. Otherwise, we can't intercept the traffic. To enable that, we have to follow this path: settings, general, about, then certificate and trust setting. Here one screenshot we have attached. In that setting, we will find that this exact similar scenario according to the screenshot. OWSP the enable full trust for root certificates for OWSP ZAP attack proxy. Now we are ready to intercept our traffic. To show enable that certificate. Once it is enabled, we are ready to intercept all the traffic. So this is the demo time. Let's see how to perform that. So we have recorded this. So this is the demo time. So as I already explained, go to the tools and there local proxy. In the local proxy, we have to just select this 0.0.0.0 with port number 8080. Without 8080, it will not accept any other port number. So once it is, we have done for the system side, let's go to the mobile device side. So here, as I explained, go to the Wi-Fi setting and in the proxy, configure proxy, there select manual and provide the server IP and port. It's done for us. The proxy is configured. So now already we have hosted our Python-based server. Okay, so let's download the root CA certificate to our device. Yes. So here you can see it is done. Even once we started download, even that is also intercepted by ZAP. So it is just asking to install. It may ask for password. So once it is installed, we have to enable the certificate to intercept the traffic. So we have enabled that. So let's intercept the traffic. So here we are just intercepting Apple HTTPS apple.com. So it is a secure site. So that's why we just thought to intercept that for a demonstration purpose. So here you can see once we hit the apple.com, it is getting intercepted. So that is all the configuration and settings for to configuring the proxy with an iOS device for mobile application security traffic analysis. Okay, passing to Milan for Android.
So coming to configuring Android devices with ZAP. Now, one of the biggest advantages Android devices have over iOS is that you can directly copy the certificate to your devices. You don't need to mail it or host a standalone Python server or something. You just connect your device to your computer and directly copy it. Now, once copied, you can install it. There are two methods basically for depending on the version of Android. If you are using an older version of Android, you can directly go to Settings, Security, select Install from Storage, and select your certificate. Or in the latest Android devices, you can Android 10 or onwards, you can go to Settings, Security, Advanced, Encryption in Credentials, and then install the certificate. Basically, once you have installed the certificate, then similar to iOS, you have to edit your Wi-Fi connection settings, add the proxy details, and put the system IP as the machine where the ZAP is running, and 8080 as the proxy listener. So this is how it would basically look once you have successfully configured your Android device with ZAP. Basically, the right side of the screen represents the Android device where I'm accessing a site from Chrome, and the intercepted traffic is shown here on the left side in the ZAP window. So let us go to the demo where I'll show this in detail. So basically, this is the certificate that you have saved. This is the certificate you have already. I'm assuming that it's already saved and copied to your Android device. Then we set up the local proxy to 0000 and 8080. Basically, this 0000 means that you are listening on all connections on the network. So basically, any traffic that comes into the this Wi-Fi network will be coming through ZAP. So once the proxy is set successfully, we will go on to the mobile device. This is the older Android version. I think it's Android Lollipop I'm using. So for now, I'll be using the older setting, that is going to Settings, Security. The first thing I'll do here is clear the credentials. Now this is important because if you have installed some other certificate previously, it will be easier that if you clear it, then only install a new certificate. Otherwise, there will be a conflict between the certificates. So then select the ZAP. And there are two places you have to select it. Once, like you select install a certificate and select your certificate, you can see the credential use section. Basically, why this certificate or where this certificate will be used. So first option, I will be using this certificate over the Wi-Fi connection. So you can just give any name to this certificate and just using ZAPCA, so that is easier to remember. You select the Wi-Fi connection. Again, I have to install the same certificate under VPN and apps. So basically, even if I'm connected over VPN or any app traffic also, application specific traffic also will be now routed through ZAP. So once that's done, just click on OK. At this point of time, you might get a warning message that network may be monitored. Obviously, since you have installed a third-party certificate of a proxy tool like ZAP, system will give you a warning message. You can safely ignore that and proceed. Then you select your Wi-Fi connection, select Add Modify Network, add the proxy details. Here, you give the IP and port. IP is basically, as I said, it is the IP of the system on which ZAP is running, and port is 88. Once successfully saved, you can come back to open your, I'm using Chrome here. In Chrome, I'm opening a demo site called demo.testfire.net, which is something that we commonly used for testing or demonstrating web application vulnerability. So it is the SSL connection. I just want to show that I'm able to intercept SSL traffic over ZAP as well. Sometime it might give an error, but just let it wait for a minute. As you can see, now the SSL negotiation is completed successfully. And if you see here in the left side of the screen, the ZAP thing is intercepted already. So now interception part is done. Let's move on to the next, that is using the emulator. Now this is a running question actually. Why we shouldn't use emulators instead of physical devices. Now, if you ask for personal preferences, we always like to use physical devices because it's less cumbersome. But depending on the requirement, emulators are also preferred because the biggest advantage they give is the cost benefit. Obviously, the devices will cost you, and you have to maintain them also. You have to constantly get them updated, or once the updates stop coming, you have to find a new device. However, emulators do not have those kind of restrictions. And there are certain testing types like memory analysis, which are much more easier because you can directly integrate the emulators with IDEs like Android Studio and directly analyze without much any additional configurations. But the emulators also have certain disadvantages. And from my experience, I'll give you some examples. We have tested in the past, we have tested certain applications which required haptic feedback feature to register a user's input. Now, those kind of things are really difficult to emulate on a virtual device. Second thing, if there are any app level conflicts, say if you have multiple apps installed and some app is conflicting with the device, that is really difficult to find out using an emulator. Also, emulators tend to be slow because they have to emulate not just the software part, but the hardware part also. For example, if you are running say you are running a emulator on an Intel device, but the emulator is basically emulating the ARM core processor Android device. So the instruction set also has to be emulated. That itself takes a lot of time. So for those reasons, it's a matter of personal preference, you can say, or it's a matter of technological restrictions. So you can either go for emulators or you can go for physical devices. If you go to the configuration part, the basic configuration of tools like ZAP or Bird suite with emulators is not much different than from the physical devices. Basically, you have to install the certificate, edit the proxy settings, and there the only difference being the proxy IPs sometimes vary because the emulator is running on the same device as a virtual machine. So moving on to the next part, the security analysis part. Now, one of the key areas that we can do with mobile application security is called traffic analysis, where we just put ZAP as a man-in-the-middle proxy in between your mobile application and your mobile application server and analyze the traffic intercepted. So for that, we can use ZAP as a proxy tool. And if you go to OWSP top 10 category, there are two major areas which can be covered partially or fully using the ZAP. These are the third one, insecure communications, or the sixth one, insecure authorizations. Now, some of the most common vulnerabilities that can be uncovered by traffic analysis using ZAP includes, but this is not an exhaustive list, so there can be many more ones. So one of them is secure communication validation, where you analyze the SSL TLS traffic or the configuration is proper or not. You can look for server-side open ports. You can search for personally identifiable information or any kind of server information that is being leaked. You can check for server-side brute force attacks or lockout validations. You can check for resource utilizations and also server-side authorizations. Now, basically here, you can say, whenever you are intercepting the traffic from a mobile device, you are analyzing the traffic in a web application context. So you can see most of the defects that you see here look kind of like the issues that the vulnerabilities that you will commonly find in a web application. To elaborate more on this, I will request Ankush to walk you through the demo for the security analysis part. So Ankush, you can take over now.
Thanks, Milan, for this information and the data. So as we covered the traffic analysis. Traffic analysis is the main part of mobile application security. So as we know, ZAP is a hybrid tool which has manual analysis and with also that it has the automated analysis part. So we can say ZAP can perform both manual analysis and automated analysis. So here just for a reference, we have added one screenshot. You can see that ZAP automatically we have just performed one scan with OWSP ZAP, and we for the test application we have taken the OWSP GoDroid. OWSP GoDroid is a vulnerable mobile application for demonstration purpose. So we just taken that one for this session. So this is the IP and server where we hosted the OWSP GoDroid server, which the mobile application GoDroid is communicating all its data and getting data from this server. So once we crawled this, we just initiated one scan. Here you can see the it is marked that a door option where we just configured the automated scan. So for the login purpose, we have just configured this context so that the tool can automatically log in and it can scan the server side part. So this is the automated scan can be performed using OWSP ZAP. So let's go to the mobile extensive mobile device part, how it is pretty much helpful to analyze the traffic, means how we can discover various kind of vulnerability, which is critical vulnerability using traffic analysis with ZAP. So let's the demo part. Okay, so here we will just perform one, we'll find one critical vulnerability privilege escalation using OWSP ZAP with the board application. So let's start. So this is the application. Here we just intercepted the application traffic. So we already log in with a user, general user. So this user has only 3 functionality we can see. Okay. So because why we are seeing 3 functionality, because this user has not the admin functionality enabled. So this is a general user. So if we see the traffic request, we can see that once the request response is coming from the server, we can mark that it is the the admin functionality is off, false for this user. So we can take benefit of this what we can say bad scenario or bad functionality of this application as our exploitation. So we have the request there. So we just turn on this interception button, and once we click login, here we just intercepted the traffic. So we what we are doing, we are just making the false to true to gain the privilege of the admin user. So we can now see what is the extra functionality is added. One is the manage user. This is the functionality of the admin. So this kind of vulnerability we can find using OWSP ZAP. This is a clear scenario of our privilege escalation in mobile application. So this is one of the critical vulnerability of OWSP top 10, and even we can say as M6 poor authorization of mobile OWSP mobile top 10. M6 is the poor authorization vulnerability. This is one of the scenario of that. Thank you. We should go with the question and answer, if you please.
So thank you, Ankush and Milan, for your great mobile AppSec testing presentation. Simon and I were talking about this the other day, and he and I were both like, we never even thought about using ZAP as a mobile application testing suite. So it's super awesome to see what you did there. I know we were talking about emulators in Discord while we were turning stuff off and turning it back on. That's exactly what we did. But any other emulator stuff you want to add while we're live here?
Yeah. Yes, emulator can be used as a replace of device, but we'll suggest for mobile application security testing, we'll suggest to use the real device so that we can simulate the real world situation. Because let's take an example of mobile banking applications. So as those application contains banking related information, and those application have some limitations. So they do, sometimes those application not compatible with the simulators like Android Studios and Genymotion, Xcode. Those are the emulators available in the market for mobile application, but those banking applications are designed in that way so that they will not support the emulators. So that's why we only suggest that to use real world device. Yes, it is a bit expensive for a lab, but that is our suggestion. And yes, in the I like to cover the SSL pinning part. Yes, FIDA is the way, but again, FIDA can bypass the SSL pinning, but the requirement is rooted mobile device and emulator. So these are the two requirements. of FRIDA, using FRIDA as a SSL pinning bypass. But there is another options are available. We can trick some binary values, like we can replace the public certificate, which is generally the developer used to store that inside the APK file or IPA file. So we can replace the that certificate with our OWSP ZAP certificate, so that ZAP can intercept the traffic. So that is another way. But in the binary changes part, the success rate is generally 30 to 40%. The success rate is not high. So generally in the market, people try to go with FRIDA.
Gotcha. That's great information. Thanks. I know. Thank you for touching on the SSL pinning too, because I know that's a hot topic, and that's kind of a hard one to get around. Thanks to, I mean, that's the whole point of it, right? It's hard to intercept traffic for a site that has SSL pinned on purpose. But I think there was another good question in the Discord about routing kind of all of the traffic on a mobile device and not just web traffic when you do that proxy setting. And as far as I understand it, when you set up that proxy setting, everything goes through that. But can you guys clarify that a little bit? Is it all the traffic, or is it just mobile or web browser traffic, or what's that setup look like?
Yes. So it will generally intercept all the traffic of mobile device along with the traffic which actually we are listening to a specific port. Here in our session, anyone we can rewind and check. We are just addressing 0.0.0.0. This is the IP address. So, and the port number is 8080. So it is not listening to any IP address. It is just listening to the port number. So if anyone is broadcasting to this specific port number, then everything will be listened by the OWSP ZAP. So in our scenario, the mobile device is pointed to the specific port 8080. So all the traffic of the mobile device, anything of the mobile device is trying to contact to the server, then it will be captured by the OWSP ZAP. One thing I will try to add that in malware analysis also this kind of scenario is helpful, because some malware are trying to establish the server communication with their remote server. So in this scenario also ZAP this traffic analysis is helpful with the ZAP.
Awesome. I may have missed it, but is there another question in Discord you guys wanted to hit? Because I was running around trying to figure out all of our audio issues. It seemed like there was a lot of great questions. I'm not sure I'm super hip on the burp question in the ZAPCon, but you know, it is what it is. Any other questions you guys want to hit, or tips and tricks that you can give people that are watching out there that are interested in testing mobile apps with ZAP or another tool that you kind of had to battle to figure out?
Yes, as you are talking about the two tools which are pretty much famous in the market, but over the another tool, I would like to go with OWSP ZAP, as it is open source and it is just offering both automated and manual analysis. So that's why I will prefer OWSP ZAP over than the another tool which you just whispered slightly. So I'll just pass to Milan. Milan can add some extra points in this about tips and trick how we can use ZAP in this scenario better. So Milan, please go ahead.
Yeah, Scott, just adding to what Ankush already said, some basic tips would be like, obviously, since we are working on your personal systems, it will be much more easier. But if you are working in a corporate environment, you are actually testing an actual application in your company, there are certain things that will often create issues, like whenever you are trying to listen to the network connections, your system, specifically your desktop or laptop, the firewall rules might be specifically set to listen over all the interfaces. So there might be, say, if you are testing it in a corporate environment or in a restricted environment, or you have certain, say, security software or something installed on your desktop or laptop, you might have to add certain exceptions in firewall, or maybe just allow some things through the maybe the antivirus tool or something. So certain things like that might come up if you are testing it in a restricted environment, like in official systems. But if you are doing it in a personal system, these things might not come up. And second thing, that something I saw in the Discord server, like uh, it's a matter of, although it's a matter of personal preference when using emulators over physical devices. Now, for security testing, we are doing it in a non-functional aspect. So we don't much think about how the application should run. As long as we have a supported physical device, we do not think of going to emulators directly, because emulators do involve some sort of, you can say, pre-setup things. Like whatever we showed here in the demo, just has a working device. You install the certificate and intercepted the traffic. That's it. Probably if SSL pinning is there, some additional steps needs to be done. However, in emulators, say for example, if I give an example of Genymotion, you have to first set up the Google Apps there. You have to install some additional tools there before you can actually configure that. So that's just basically some additional hassle. So if you have a physical device with you available, so the better way will always be to use the physical device instead of setting up a emulator. So that's about it.
Awesome. Great information, you guys. Hey, everyone, thank you for hanging in there with us with our technical difficulties. There's more great stuff happening in the Discord chat room. Everybody in the Discord chat, please give Ankush and Milan a big virtual thank you. Thank you for your great presentation. A really interesting way to use ZAP and really good insights for people that want to do the same kind of thing. I think we're going to take a little short break. The next session is supposed to start at 1 minute ago. Let's give like a 2-minute break. We're going to do a little bit of tech checking on this side so we can make sure the next session starts off without a hitch, and then we'll be back. So we're about 2 minutes behind right now. We'll probably catch up in the next session. But once again, thank you, Ankush and Milan. It's great to talk to you today. And thank you so much for staying up late and hanging out with us at ZAPCon today.
Thanks, Scott. Thank you, everyone.